The next type of ionic compounds that we're going to look at are called complex ionic compounds. The reason why they are called complex versus the ones that we worked with earlier that are called simple ionic compounds is because the cation in the formula can have more than one oxidation number. For example, iron can either be 2 plus or 3 plus, meaning it can give away 2 valence electrons or give away 3 valence electrons. When we are naming these complex compounds, we use Roman numerals in the name, and the Roman numeral tells us what the oxidation number is. So iron 2 means that this iron ion has a charge of 2 plus. Iron 3 means the ion has a charge of 3 plus. Now, how do we figure out what the Roman numeral is? So I have a compound here. I have the formula for the compound, and it's Fe2O3. All right. I'm going to put up here positive and negative. And the reason why I'm doing that is just so we can all see that this is the positive ion, this is the negative ion. I don't know what the charge is on this one, but I do know what the charge is on oxide. So the anion will help you figure out what the charge should be on the cation. So let's use oxide. All right. The first thing I'm going to do is find oxide on either my periodic table because it's made from oxygen or on a chart that you may have with the ions listed. So O2 negative. So the charge on oxide is 2 negative. I look at my formula and I see that I have 3 of them. So I'm just going to write it down 2 more times until I have 3 oxides, each with a 2 negative charge. If I add up all of the charges, I see that it is 6 negative. Now, earlier we discussed that ionic compounds are neutral, meaning that the overall positive charge will equal the overall negative charge. So if the negative is 6, then the positive has to be 6 as well. I go back to my formula and I see that there are 2 Fe's. Fe, Fe. These 2 Fe's have to add up to be 6. All right. Both of these together equal 6. So what I'm going to do is I'm going to take the 6 divided by 2, and it's going to give me what the charge is for each of those. 3 plus, 3 plus. So now I know that the charge on this iron ion is 3 positive. So when I name it, I use the Roman numeral 3. So I put the name iron 3, and then O is called oxide. So iron 3 oxide is the name of this. All right, let's look at another example. All right, let's see here. Let's do okay, PbO. All right. Once again, I'm going to use my O to determine the charge, because remember, this is my positive one, that's my negative. I'm going to always use the negative to determine the charge on the positive. So the O is going to determine the charge on the Pb. All right. So O has a charge of 2 negative. According to my formula, there's only 1. So the overall negative charge is 2. The overall positive charge has to be 2 as well. So I go back to the formula and I'm looking to see how many PBs are listed. There's no subscript, so it's understood to be 1. So this 1 PB adds up to the charge of 2 plus. Okay, So the name is lead 2. That's the Roman numeral. It equals the charge on the cation, lead 2 oxide. And it is only the cation that gets the Roman numeral, okay? If you have any questions, please let me know.